Hello everyone, in this video we're going to learn network analysis, and there are about 3 tasks here in this lab. So the toolbox, the network analyst toolbox, helps us to develop, manage and analyze the transportation networks. The data has been provided in Canvas, so these are the data that you will require to do the tasks. There are also links to some of the tools, so you can also check the links given. So different types of data we will need for different tasks we will do in this lab. So at the very first, we actually need a network dataset. So the network dataset has already been provided. You can use that one. Then we will do one is we will create a route. Then another task, we will create a service area, and the last one is to create a location-allocation map. So I have connected the folder to the data, and from here I will add the streets network dataset. You can see that the network dataset has already been built, so you do not have to build the network dataset again as instructed, because the network dataset has already been built for you. So you can skip the very first step of building your network dataset because it's already been built. It contains all the routes and the directions to the routes and everything. Now we're going to create a route. This route we will use the route from the network analysis tab, and we will create 5 stops and if we eventually run the route analysis, it will show us that which will be the best route for us to go from stop 1 to stop 5. You can change the color symbology if you want, and you can take the 5 stops randomly. I'm trying to put them scattered over the network dataset. I have added 3 points to one side and the other 2 on the other side. So this network analysis helps us a lot to do and solve this kind of problems. We also have to rename the sequence field and the name field of this 5 stops that we created, and don't forget to save your features after creating those. So I'm providing the sequence here and also the name of those. So there are so many network analysis tools that helps us to solve particular transportation problems. particular spatial problems related to business, health shortages, health accessibility, then emergency transportation, and so on. So this tool is of great help. Now if you go to the route layer, we have our 5 points, 5 stops. Now we will use the current sequence, the one that we used to create the stops for our first run. You can clear selections, that's not a big deal. So this time the analysis will use the current sequence that we have provided, and it will show us the best route to go from stop 1 to stop 5 while visiting each of the stops. So you can see that we can see the routes here, and we will also check that if we change the option to preserve the travel option to preserve first stop, it will actually simply preserve the first stop and give us the best route to go from stop 1 to stop 5. You can see that there are no changes because this was the same result for when we kept the sequence, the one that we created, and also when we take it, when we run the analysis as the first stop. So I'm trying to make some changes to the stop and trying to see that whether we see any changes to the stops or not, to the route. So it actually showed the same results for both those options because it did find the same route for my previously manually given provided sequence, and also if we keep the stop 1 consistent and the other ones to be anything that the tool finds to be the best. You can see that it actually changes now. Now, when I have changed this, you can see that this time it provided 2 different routes for 2 different options, so you can make any kind of changes there and see. You can change the stops and you can see that, find out the best route using this tool. Now we will add a polygon barrier to our route and see that how the analysis finds out an alternative route avoiding the polygon restriction, the restriction polygon that we are creating. So I'm trying to cover up a large part of our previous route. Saving the restriction polygon that I've created. Now if I run the analysis again, you will see that it is trying to give me an alternative route, but you can see that I am not able to reach stop 4 and stop 5 because this particular polygon have obstructed the only route that can lead us from stop 3 to stop 5, because there is a bridge we can see. So the previous polygon that I've drawn, it obstructs the path of that single bridge. So I'm making a smaller one to show you guys. And after saving this one as well, I've deleted the previous one. Now if you run the analysis again, we can see that here comes the best route from stop 1 to stop 5 while avoiding the polygon restriction. Now if we try to see the directions, you will be able to see so, like exactly how we can reach from stop 1 to stop 2 and so on. We can also save this directions as a PDF file. Simply click on print and save it wherever you want. It will not you do not have to print it physically. Whenever you click on print, it will be saved as a PDF format, and this will be one of your deliverable. So your PDF will look somewhat like this one. It will also show you the approximate time you might need to travel from one stop to another and to the end. Now you have to create a map of the route from stop 1 to stop 5 along with the polygon, the restrictions or barriers it might have. There might be other restrictions like line points and so on. So this is just one restrictions that I have added for the tutorial. Okay, after creating that layout and map, you can simply provide it as a deliverable. Now we are going to create a service area, and this layer is simply provides this problem. It solves the problem of locating or providing some services to particular neighborhoods. And for now, we will use the fire stations to see that one fire stations can provide services to how many surrounding neighborhoods within a specific time. So this is a service area. It might be a hospital or any kind of other facilities. So this particular tool will help us identify some service area provided by a particular facility. Okay, for that you have to drag the fire station points that we have over this network dataset, and remember to take another map to do this task. We are not going to use the previous map for this. So if you can see that there is no service layer available, service area layer. If you click on it, the service area layer will appear and you will see your options. From here you have to import the facilities where you are gonna run your analysis. Like we want this fire stations to be our facilities, and we will see that which fire stations are serving which particular area within a specific time according to their position. So we will set a cutoff time of 4 minutes and see that which particular fire stations can provide services to its surrounding neighborhood within a time frame of 4 minutes. You will see many overlapping polygons here, which says that some neighborhoods can be served by more than one fire stations within a time frame of 4 minutes. And we have also used that overlap options for our output geometry. That's why it's showing us overlapped polygons here. So this is an amazing tool to allocate service areas or find out shortage areas where the services might not be served within a particular time frame. So if we change the geometry type to split, the output results will show separate splitted polygons, which will show that yes, this particular area is best served by this fire station, and the boundaries of two polygons actually show that these boundaries or the neighborhood that falls under these boundaries can be served by both of the fire stations or 3 or 4 of the fire stations surrounding it within a same time. So 2 fire stations are equivalent where the polygon boundaries are located. So this particular boundary can be served by both of the fire stations we can see here. Now we will use 2 minutes and 4 minutes as cutoff times, and we will use the dissolve as the output geometry. And if we run the analysis for the last time here, we will see some areas where the services can be provided within 2 minutes, like the dark blue area denotes the areas where services can be provided in 4 minutes. And so if we change the symbology, like I've just changed it to green, so the green areas are the areas where the fire stations can serve within 2 minutes, and the reddish areas are areas where the fire stations will take more than 2 minutes to arrive in those places, or 4 minutes. So this will be your deliverable 2, which shows service areas for different fire stations to their neighborhoods. And you can see that it will show us that which are the areas that particularly denotes shortages, or you can see that there are so many neighborhoods where fire stations cannot serve within a time frame of 2 minutes. They need more than 2 minutes to reach out to those places. However, it is still a good one, because most of the fire stations can reach to these places in 4 minutes. So we will head to our location allocation task. This is the most important one, and it is an amazing, more real-life example of using this network analysis tool. So we have candidate stores, then existing stores, tracks and traits, and competitor stores to do this particular analysis. We can take another map for this to do this task, and we can drag all the data that we have to perform this particular analysis. So these are simple. Try to understand that what we are going to do. Actually, we have some candidate stores or potential locations of some stores that the owner of that stores, or like suppose I am the owner of this store, I want to make those stores located in some of the places. So those are the potential candidate stores. And the competitor stores are the stores where there are already some stores located, and I want to snatch away the customers of those competitor stores using my new candidate stores, and there is one existing stores that I already have, so I don't want my new stores to be located nearer to my existing store because it will steal my own customers. And then we have the track centroids. It is the place where actually people live, so we would like to locate our candidate stores to the particular places where the store can attract the most of the track centroids or the customers. For that, we have to first import the facilities. Like we will import the candidate stores, the potential locations. We don't need to provide any of these values for this particular one. We can keep this as default. For the facilities, now these are the places where we have plans to build our new potential future stores, and we can see that there are other facilities that we will incorporate one by one. We have to provide the demand points as well, like the centroids, and from here we have to provide the weight of, as the population of this centroids will be the weight. The more population, the more focus will be given to those particular track centroids to be served by our candidate stores. So you can see that the track centroids, the demand points, and the facilities have been provided. Now we will have to change some of those options or analysis type, and we will provide a cutoff time of 5 minutes, and we want the analysis to find out 3 candidate stores, 3 locations for the candidate stores where the surrounding neighborhoods or the track centroids will be in a cutoff time of or a traveling time of 5 minutes. The problem type we will provide as the maximum attendance, because we are considering that this is a perfect type to solve like this kind of retail store locations, because we are giving that most of the all of the stores are considered equivalent to the customers, and these are the 3 stores we find out, the chosen 3 stores we find out after doing our analysis, which shows that this stores can be reached by its surrounding neighborhoods within a time frame of 5 minutes. And simply the problem type, the maximum attendance, refers to that the customers would like to travel to its nearest store, because all of the stores are considered the same. Now if we take our existing stores here as a required one, it will simply force this analysis to take the existing stores that we already have as one of the chosen ones. So it will change the analysis now. You have to take it change it to a required one. Now you can see that we have our existing store that still we didn't run our analysis. If we run, so we will see changes, because now it is showing a store to be located nearer to our existing store, but as we already have a store in that particular area, we don't need to locate our new store or build our new store nearer to our existing one. So if we have taken our existing store to the facilities, and now you can see that we are seeing total of 3 facilities, because we have provided 3 facilities there in that option. So one is the existing one, and the others are the 2 that also attracts most of the neighborhoods that are in a travel time of 5 minutes. Now if we provide the competitor stores as well here, it will make our analysis more realistic, because we might have already some stores there located of different owners, and these stores are already served, and people might go to those stores as well. So now we will use a different problem type to solve this problem, which is maximum market share, and this problem will allow us to take the market share from that particular existing competitor stores. We will use that particular option of function type, cost transformation function type, and the power that we will use is 2. The more the power we will provide there, it means that the more customers will hate to travel to farther distance. So to solve this kind of problems of locating stores, locating new stores while competing with the existing stores, we will provide this market share type, and we will change the power to 2. The maximize market share will analyze the problem in such a way that we can get most of the customers that are not nearer to the existing competitor stores. You can see that now the candidate customers has been different, the chosen ones has been different than the earlier ones, because now you can see that it locates to particular areas where there is not a competitor store, because now it is able to serve to that particular area where there are no stores, and so therefore it will be far from the areas where there are already existing competitor stores. So the location allocation analysis tool helps us to identify new location of stores, that while keeping in mind about the existing stores and also the influence of the competing stores that it has already on its surrounding neighborhoods. And the maximize market share type problems helps us to solve this problem as well. So your final output will be a layout map of this particular one with 2 additional chosen candidate stores. You can just simply do it by changing the facilities from 3 to 5. It will show you more 2 locations of your future potential store, which will try to attract most of its neighborhoods while keeping in mind about the existing one of yours and also the competing stores that you that might be trying to take or steal your customers. So your new location will be in such areas that will maximize your market share and grab the most customers. So these are the 3 deliverables, and I hope this tutorial was helpful. Thank you.